One second. So, at the end of this session, learners must be able to calculate percentage of fractions. Calculate percentage of fractions. Learners should also be able to calculate percentage increase or decrease in a quantity. Learners could also aim to apply percentages to savings, borrowings, and wages, and learners will be assessed on their ability to understand how to calculate percentage increases and decreases. You will be familiar with seeing percentages in everyday life, such as discounts on goods in shops and online, increase in wages, interest rates offered on savings, interest to be paid on loans. So this is an important topic to understand and master. For example, a phone cost £80 last week, but the shop is now offering it with a 5% discount. How much does it cost now? So we find the solution of 10%, which is 80 times 1/10, which is £8. To find 5%, we halve the result. So dividing by 2 gives us £4. So £5 of 80%, 5% of £80 is £4. So the new price is 80 minus 4, which is £76. So calculating percentage increase or decrease, new value, take away original value, divided by original value times 100. So in a business or commerce, it is also important to be able to calculate a percentage increase or decrease over in the relevant context. For example, the price of a litre petrol has increased from £1.20 to £1.35 over a period of 6 months. What is the percentage increase? We need to use this formula, new value, as I said, new value, take away original value, divided by original value, multiplied by 100%. So in the context above, the percentage increase is 1.35, take away 1.20, divided by 1.20, multiplied by 100%, which equals 0.15, take away 1.20 times 100%, which equals 12.5%, guys. So increases in postal rates, new value, take away original value over original value times 100. Postal rates increases in the UK are decided by the government in consultation with Royal Mail. For example, the cost of a first class stamp for a small size letter in the year 2000 was 27 pence. In 2019, it is 70 pence. What is the percentage increase? So using this formula again, we will do 70 take away 27 over. Actually, it's 0.7, take on 0.27 over 0.27 times. If we do this, it becomes 0.43. Yeah, if we do that in our calculator, the 0.4 we divide by 0.27 multiplied by 100 equals 159.26 to do decimal places, so it's a 59% increase. So, sorry, what have I done there? So you take away 20. No, that's wrong because it cannot be that, it cannot be 53 as 0.7. Wait, so let's do this again, guys. Um, Let me do this again because we know that's written wrong. Okay. So so the original value was 27. I mean, the new value is 70. The original value is 27. The original value is 27 again. Multiplied by equals. It's 43. Definitely not 53. Let's equal by 27 multiplied by. Yeah, so the answer is 59%. As I said, guys, the increase is 59% to one decimal place. As the answer we get is 159.3, which means that it is one, which means that it is 15%. That's the increase, guys. This is a considerable increase, but both wages and prices have also increased over this 19-year period. Is it a fair increase? To answer this, you will need much more data, such as the rate of inflation over this period or comparable increases in transport cost. Another important application of percentages is to work out how much interest can be earned on savings and also how much you will be charged if you borrow money. We will look at the borrowing money later. My bank offers to pay a 10% interest a year on any money you invest with them. So if you invest £100, after 1 year you will receive an interest of £10. Often you will leave your savings in the bank for a number of years, and this will continue to receive interest on any money in the account each year. This can continue year by year. So next year you will invest 100 plus 10, which equals £110, and receive interest at the end of the second year of amount £11, because 10% of 110 is 11. Now, if you have 110 plus 11, £121 to invest in the next year, now you will have that compound interest. When we reinvest the interest each year, it is called compound interest. We will see now how the value of an account increases each year. Here is the account over a 6 year period can complete the entries. So year one, start as 100, interest earned is 11, 10. So the account at the end of year 110. Year two, 110, interest earned is 11. Account at the end of the year 121. Year three, 121. Interest earned is £12.10 pence. Account at the end of the year is 133.10. So interest earned is 10% of that, which is 1331. So at the end of the year, it equals to 133.10. Add 13.31. 1, 4, 1, 4. And then 10% of that is 1464. 1464. No, add 1464, which equals 16. Um, 131. This is what. By the way, if you have any questions, just let me know. Um, don't hesitate to ask. 161.05. 10% of that is £16.11 to want to do decimal places. And then if you add 16.11, yeah, 1. Yeah. So if I rub these out, you'll see my calculations are correct. Yeah, 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 yeah. Yes, yes, yes. Compound interest formula. There's in fact a formula that gives the total at the end of each year. If you invest £8 and the interest rate is R%, then after n years, the account will be worth value of account equals A 1 plus R divided by 100 all to the power of n. We will check this example here for the for we will check this for the example above. A is 100, R is 5, N is 6. So all we would do is 100 equals 1 plus 5 over 100 all to the power of 6, which equals 105 to the power of 6, which equals 105 to the 6. So 1.05 to the power of 6 equals 1.34 to do decimal places. That again is wrong. Sorry, guys. It's wrong because why is it making 11 over 10? Firstly, this should be 5, as R is 5. And if we do 1 add 1 add 5. Yeah, equals 1.05 again. Should be there, 1.05 to the power of 6. How long will it take to get 200? This is easy to calculate as 1. 1.1 to the power of 7 is 1.989487. So and 1.1 to the power of 8 is 2.14358. So after 8 years, £100 will be invested. £100 invested would be £214 36 pence. But again, this is wrong because it has said that R is 5. Now here it used R as 10. So this calculation is wrong, guys. So don't follow this example. Um, Borrowing. This works in a similar way to saving, except that you have to pay back the original sum borrowed with interest added in each year. This can be very dangerous, particularly if you use loan sharks to obtain the money you want. Suppose you borrow £500 at the beginning of the year with an interest rate of 30% per year. How much would you owe at the end of the first year? So for 30% of £500 equals 10% is 50 times 3. It equals £150 you would owe them. 10% is 50. Multiply it by 3. £150 you would owe them. Oh, sorry, £650. You add the 500 you have borrowed, and the answer is £50. Again, if you cannot pay that back at the end of the second year, you would increase it by 30% again. So 30% of 650 is 65 times 3, which is 195. 195 add 650 equals 845. So beware when borrowing money. Make sure you can pay back the loan ASAP. Borrowing, take care. Complete this table and see how much you will owe after 5 years, having borrowed £200 with an interest rate of 25%. Where needed, work out to the nearest penny. That means do decimal places. So £200 borrowed, £50 interest, £250 at the end of the year is owed. £250 borrowed in the second year, £62.50 interest, £312.50 is owed. £312.50, again, 25% of that is 10% is £32.25, 20% is 31.25, 20% is £62.50, and then 5%, £62.50, and 5% is £31.25 divided by 2, which equals 31. Two equals £15.63 plus 15.63, which equals plus 62 plus 50, which equals 78. I mean £78.13, sorry. So interest to be added over 78.13. Account at the end of the year at 312 live. So it would be 390 63 pence. Yep, that's right. The next one would be 390 63. No, 25% of that. We can actually do it on a calculator. Little like what is it? Um, so 390 times 0.25, 90.63 times 0.25. equals 97 pound 65. 97 pound 66 pence. £7 66 pence. So 1 second, sorry. So add that to 390.63 equals 488.29 and 488.29. 25% of that is multiply it by 0.2. 122.7 pence. Add that to 488.29, which equals 610.36. So that's the final answer. If we rub these all out, we'll see the answers behind it. 32 and 13. Yeah, that's correct. Sorry. That's correct. That's correct. That's correct. That's correct. That's correct. That's correct. In practice, it can be much more complicated with interest charged monthly or daily until you have paid back the loan plus interest. It is important that you fully understand the terms and conditions for any financial loan before agreeing to it. Wages. When you are paid wages, you also have to pay tax and national insurance, depending on your age and wage. Here we will consider an increase in wages. Suppose you're paid £12 per hour for working 8 hours a week in a cafe. You are given a pay rise of 6%. How much extra will you receive each week? So 8 hours a week, 12 times 8 hours. So you earn £96 per week. Now increase of 6%, so £96 multiplied by 1.06. That is an increase. So 96 multiplied by 1.06, which equals 101 £76. Now we got 1.06 because we know that 6% equals 0.06. However, it's an increase, so this must be 100% or 1. So 1 and 0.06 equals 1. 6. So that's what would be. So how much extra you receive per week? Yeah, so per week you would receive extra. It would be £5.76. It should be because obviously the increase is £5.76. Let's see what this says. So 0.06 multiplied by 10. Yeah, but that's per hour you would receive 72 pence. So you work 8 hours per week exactly. So the answer is £5.76 per week increase. So metric units, we will start with revising metric units of capacity before moving on to conversions between metric and imperial measures. In metric units, liters are the key measure, and we have smaller units, centiliters and milliliters. They are related by 1 centiliter equals 10 milliliters, 1 liter equals 100 centiliters, and 1 liter equals 1,000 milliliters. So example, what is 27 ml in CL? So as we can see, we look at this one CL equals 10 milliliters. So 27 milliliters equals 2.7 centiliters. Yeah, you just divide it by 10. 350 centiliters to liters. So centiliters to liters. 1 liter is 100 centiliters. So 350 centiliters divided by 100 for 3.5 liters. Yeah. What is 450 milliliters in liters? So 1 liter is 1,000 liters. Therefore, 450 milliliters divided by 1,000 equals 0.45 liters. Yeah. What is 2.5 centiliters? I mean, liters in centiliters. So again, we look at this one. We get 2.5 multiplied by 100, which equals 250 centiliters. Again, 2.5 centiliters into milliliters. Again, you just multiply it by 10. So 2.5 multiplied by 10, which equals 25 ml. Yep. Imperial units. The imperial units for capacities are gallons, pints, and fluid ounces. They are related by 1 gallon equals 8 pints, 1 pint equals 20 fluid ounces, 1 gallon equals 160 fluid ounces. 1 gallon equals 8 pints, and 1 pint equals 20 fluid ounces. So convert 2.25 pints into fluid ounces. Again, 1 pint is 20 fluid ounces. So 2.5 multiplied by 20 equals 50 fluid ounces. Yeah. 36 pints into gallons. So 1 pint is 8 pints is 1 gallon. So 36 divided by 8 equals 36 divided by 8 equals 4.5 gallons. Yeah. 3.24 gallons into pints. So again, 1 gallon is 8 pints, so you multiply 3.24 by 8, which equals 3.224 multiplied by 8 equals 25.92 pints. Yeah. 68 fluid ounces to pints, so 1 pint is 20 fluid ounces, so 68 divided by 20 to get it into pints. 68 divided by 20, which equals 3.4 pint. Yeah, again, correct. Conversion between metric and imperial units. We can now convert between metric and imperial units using these approximations. So here's a table. Again, convert these complete these conversion tables using the approximations above. Again, here's the centiliters to fluid ounces. So 480 multiplied by 0.352. 480 multiplied by 0.3, 352 equals 16. 8.96 to do decimal places. Again, to get it to centiliters, all we do is 120 divided by 0.352, which equals 340.91 centiliters. Again, 250 multiplied by wait, 352 equals 88 fluid ounces. So 24 liters to pints. Liter to pints is here again. Mhm. Yeah, so liters to pints. So 24 liters multiplied by 1.76. So 4 liters multiplied by 1.76. 1.76 equals 42.24. Again, pints to liters. So 40 multiplied by naught. We can follow this one, so it would be 40 multiplied by 0.568. So 40 multiplied by, so 40, sorry, multiplied by 0.568 equals 22.72. Again, 150 liters times 1.76 pints. So 150 times 1.76 equals 264. Again, all my answers are correct. If we move this out, sorry, sorry guys, 1 second. There you go. Yeah, correct. So scale drawings are accurate plans drawn to given scale to a given scale to be used by builders and construction workers when working on projects. Here is an example of a plan of a workshop and store. So here is a plan for the ground floor of a house. The scale is 1 to 120. So what is the total width of two windows in the lounge dinner? So again, one square is this is 5 centimeters, 1 to 120. So the total width equals 5 times 100, which equals to 600. Okay, 600. Now the lounge dinner. 600. The combined width on the plan. Wait, so 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 4. So, so the combined width on the plan are 3 centimeters. Okay. So so 3 times 120 equals 360, which is 3.6 meters. What is the floor area of the kitchen? On the plan, the kitchen measured by 1.5 centimeters, 1.5 centimeter by 2.5 centimeters. This kitchen, this this is 180 by 300 in the actual kitchen. So the area is 180 times 300, which is 54,000 centimeters squared, which is 5.4 meters squared. What is the total floor area of the lounge diner? The lounge diner is formed by two rectangles on the plan. One 3.5 centimeters by 3, the other 2.5 by 1.5. The smaller rectangle has the same area as the kitchen. The larger one is 420 times 360, which is 151,200 centimeters squared, which is also 15.12 meters squared. So the total area is 15.12 add 5.4, which equals 20.52 meters squared. In in practice, we often have measurements and a rough sketch to make an accurate scale drawing. For example, the diagram opposite is a rough plan of a room. We need an accurate plan to a scale of 1 to 50. We write this as a ratio 1 to 50, meaning that 1 centimeter on our accurate plan will represent 50 centimeters in the actual room. The length 3 is 300 centimeters, and so we are working on a scale of 1 to 50. We divide 300 by 50 to give the length 6 centimeters in our plan opposite. 5 meters equals 500 centimeters. 500 centimeters, 500 divided by 50, 10 centimeters on our plan. 2.5 is 5 centimeters on our plan, and similarly, so on, as shown opposite. Scale drawings are also used for maps. Here is a map of England drawn to the scale of 1 to 4 million. On this map, the actual distance does 1 centimeter. What actual distance does 1 centimeter represent? So that equals to 40 kilometers because four, yeah, on this map, the distance from Exeter to London in a straight line is 6 centimeters. Therefore, what is the actual distance? You multiply by 6, which is was 240 kilometers. The actual distance from Birmingham to Manchester is 120 kilometers. So you divide it by 6, which equals 20, divided by 40, sorry, which equals 3 centimeters. So map scale conversion, complete this table of conversion from maps to actual distances. So 1 to 50,000, so 8 times 50,000 equals 400,000, which equals to which equals to 0.4 kilometers because 400,000 is the centimeters. Sorry, and then 10 kilometers. So 1 to 25,000. So all we do is multiply 10 kilometers. Actually, we just convert 10 kilometers into centimeters, which equals 1 kilometer equals 1,000 equals Second, I'm just thinking, yep. 9 million, which equals 9 million, yep, 10 million. So it's 40 centimeters, 8 centimeters to 20 kilometers will be a ratio of 1 to 125,000, and 4 centimeters would be 200 kilometers. This is because we have to do conversion kilometers to meet km to cm conversion. We do. So we know that kilometers is 1,000 meters, and we know that 1 meter is 100 centimeters. So then we would do 100 times 1,000, which equals to 100 times 1,000 equals to 1 million. 1 million. So that's the conversion. Now, if we convert 10 kilometers, we do 10 times 1 million equals to 10 million. Yeah, which equals to 10 million centimeters. Now, 1 centimeter is 25,000 centimeters. So if we divide this by, I'm just trying to think, 10 million. So we've got it into centimeters now. Yeah, if we divide this by 25,000, we get the answer. Sorry, 1 second. Have I done this wrong? 100 times 1,000 equal. Actually, this isn't a million. Sorry, ignore me here. This is 100,000. That's 100,000. So that would be 100,000, which means that would be 1 million. That would be 1 million divided by 25,000, which equals 40 centimeters. So that's how you work out the first one. You do the conversion. 1 kilometer is 100,000 centimeters. Again, so again for this, what you would do is 1 second. What you would do is again always remember the conversion. 100,000. So 20 kilometers equals 20 km equals 20 times 100,000, which is 2 million. 2 million. Now, to get to 8 centimeters, if to get to 8 centimeters, what we do is divided by 8, which equals 22 million divided by 8 equals divided by 8 equals 250,000. Okay. So this should be 250,000 actually, guys. This is 250,000. And then the final one, 1 to 5 million. 1 to 5 million. So we know that 4 times 5 million equals 20 million. 20 million divided by 100,000 equals 20 million divided by 100,000 equals 200 kilometers. Compound measures. In previous units, we have looked at measures of length, weight, and capacity. Here we will consider some compound measures such as speed, density, rates of pay. Speed, you probably have some knowledge about speed. You can walk fast at about 4 miles per hour, run at about 10 miles per hour, and cycle at about 20 miles per hour. On a motorway, you are allowed to travel up to 70 miles per hour, and the fastest the train travels is 125 miles. What does 4 miles per hour mean? 4 miles per hour means that if you continue at this speed, you will travel 4 miles in an hour, whereas the high speed train travels 125 miles in the hour. What is the we calculate the average speed by dividing the miles traveled by the time taken in hours. So, for example, Lucy drives from Plymouth to Southampton. The journey is 161 miles and it takes 3 hours 30 minutes. What is her average speed for this journey? So again, speed equals distance over time, which means that 161 miles divided by 3 hours, 30 minutes. We can do this into minutes for now. So 161 divided by 3 hours and 30 minutes. Again, so this is average speed 161 over 210 multiplied by 60. Yeah, so sorry, you can just do 161 over 3.5. Yeah, which equals 46 pH. Average speed. A lorry driver keeps a record of each journey he makes. Calculate the average speed for each journey using the table below. So start time to finish time, distance mile. Remember S equals D over T. So here the time would be 4 hours. Distance travel 172 miles. So the total would be 172 divided by the hours, which would be 43 would be here, 43. And second one would be 280 divided by the hour difference is 5 there. 280 divided by 5, which equals 56. And then this will be 300 divided by 6, which would be 50. 300 divided by 8, sorry. 300 divided by 8 would be 37.5. And then there would be 120. 120 divided by 2.5, because that's 2.5 hours, which is 48 miles. And then the final one would be 174 divided by 5, which would equal 34.8, 34.8, 43, 56, 37.5, 48, and 58. It would not be 58 because if we look at it, it is 5 hours here, 5 hours. So speed is 174 divided by 5, which if you want to do on your own calculator, it is 34.8, not 58. I don't know why I said 58 there. As well as calculating speed, given the speed and time, you can calculate the distance traveled. For example, if you travel at 60 miles per hour for 3 hours, you are traveling a distance of 180 miles. Similarly, you can calculate the time taken by dividing the distance by the time taken. For example, 153 miles in 3 hours. The time taken, sorry, that's wrong. What's written there, just ignore that. The formula that we have been using are summarized opposite. So Jane drives at a speed of 45 miles per hour on a journey of 135 miles. So time equals distance over speed. So distance is 135 over the speed 45. So the time taken is 3 hours, guys. Chris Chris cycles at an average speed of 8 miles per hour. 8 miles per hour. If he cycles 6.5 hours, how far does he travel? So distance is speed time. So 8 times 6.5, which equals 8 times 6.5, which equals 52 miles. Yeah, so that's correct. Density. This is another compound measure for how dense a material is. For example, a container full of sand would be much heavier than the same container full of air or full of bubble wrap. This is because sand is much more dense than air. Density, weight, and volume are connected by the relationship density equals weight divided by volume. Weight equals density times volume, and volume equals weight divided by density. Example, a metal block has a weight 2 kg. The block has dimensions 5 by 10 by 20. What is the density of metal but in grams and in kg? So the density is the weight over the volume. So to work out the weight is 2000 grams. 2 kg equals 2000 g grams. 2000 grams. 2000 grams equals, yeah, so that's grams. centimeters. So the volume, so the volume is 1,000 centimeters. So 2,000 divided by 1,000 equals 2 grams per centimeter. The weight is 2 kg, so it would be 0.002 grams per centimeter, kilograms per centimeter. Sorry, you just convert it into kg. The density does not change, but its value changes with the units used. Other compound measures, average scoring rate. So average scoring rate in football, Alisson scores 27 goals in 40 matches. Calculate her goals per match, goals per minute, and goals per hour. So 40 matches, 27 goals per match, 27 divided by 40, 40 not 400, equals 27 divided by 40 equals 0.675. Um, Again, B is per minute. She has played 90 times 40, so she has played that many minutes. Equals 90, 90 times 40 equals 3,600 minutes. Multiply, divide, so 27 divided by 3,600. 27 divided by 3,600 equals 27 divided by 3,600 equals 0.7 per minute per minute. And the final one per hour. So how many hours? There's 1.5 hours in one game. So we would do 40 times 1.5 equals 60 hours played. 60 hours of football played. And then you would do 27 divided by 60, which equals 27 divided by 60, which equals 0.45 per hour. So the answers are 0.675, as I said here, and then 0.075, 0.075, and then 0.45. So yeah, that is today's lesson. Thank you for joining, appreciate it. And if you have any questions, let me know. Otherwise, I will stop the recording and you can go.